Welcome back for yet another exciting C# web tutorial. To be honest, there's not many more to view, and I hope you enjoy this. If you remember in the previous one, we dealt with arrays. Arrays were like solar panels. The same data type, just like the same dimension of the panel, is loaded contiguously in memory. And one of the reasons we use arrays is they're quicker because they're right next to each other in memory, and it allows us to process like data, such as test scores, all in a row very quickly using a loop. However, one issue with arrays is you need to know how many elements you need in the array. Remember, I needed 8 test scores, or I needed 10 names. We're going to introduce you to something new called lists. There's lists, queues, and stacks. And they are like dynamic arrays. They're like arrays that you can add to, and you can remove to, and compress as needed. So let's take a look at the code. Standard form here. Notice I have a button for each of the different things we're going to talk about. Lists for strings, a list for integers, sorted lists, queues, and stack. Before we go any further, at the very top of the project, you must have this, using system collections generic. See my comment already put in there by Visual Studio. If it is not there, you have to add this line of code by taking away this. What we're doing is we're making C# extensible, taking advantage of how we can add to it. Alright, let's get back to the form and let's look at these strings. Now the difference is you have to use the list object. Notice it's kind of that aqua blue. But in these angle brackets, these are called angle brackets, you put the data type. And then the name equals new list, which is this object, of the string. So pretty much you repeat this is repeated from here. And I want 3 elements. So we have initial size of 3. So I add, kind of like how we add items to a list box, we add Candido, Smith, and Lambert. So initially it had 3 in a row. We are now going to add the 4th element, which will automatically expand, and we add these values. Now, if you're wondering, lists are a little slower than running arrays because it has 3 grouped in memory and then adds another 3 grouped in memory. Built into the list is a sort method, and we can use the for each just like we did on an array. We use the list name. See, here's the list name. And each value one at a time is put into here, and we process it, and we go up and get the next. And also, the list has methods and properties. It has a count to tell how many are in it. It has a capacity to tell how many more it can fit. It can get to the first one. I can position to the last one. I can get a specific value. So notice right here, similar to arrays, I put the name of the list, square brackets, not angle brackets, not parentheses, in the element. This gets me the second, because remember, elements in a list are just like the elements in an array. You access them 0 through 1 less than the length or the count. Okay, I can see if a value is in there. Tell me, list, do you contain the value Candido, and it will return back a true or false. If you hover on contains, it should show you it returns a Boolean, and it takes in a string item. We can also say, does white contained in the list, and it will tell you true or false. We can also insert. So if I have everything in the list, I can say insert comment after this position, and then I can process the elements all over again. And then I can check to see if I need to add something. I put golden into this variable. I say list, do you contain this value of golden? If it does not, it will add it to it. See the not, which means does not contain, and does it. Alright, so we have a breakpoint right here. Now notice the declaration's a little funny. You put lists, then angle brackets, the variable type, or the name, or the data type, the name, and here is just kind of a repeat equals new list string and how many you want. Alright, let's run this. Okay, click here. We step through. We add some values. We're about to expand it because we initially only wanted 3. See the 3? And we expand it. We sort it. We process each entry in the array. In the interest of time, I'm just going to skip over that by putting a breakpoint and hitting F5. And we write out to screen how many. Look, I can hover on here and it will tell me there's 9 in there. The capacity is 12. And the reason is we add in segments or extensions of 3. So right now the count is 3, but we can handle 3 more because we actually have room to grow. And we step through and we ask what the first element is, what the last element is, what the specific element is. I could put any number in here between 0 and 9. I ask if something's in there, and we process the values in the loop after we inserted them, and then we check. I'm going to breakpoint over that. We check to see if golden's in there, and we add it. There you go. So here's the values. It tells me how many. So you would use a list when you know you want to process things as a group, like the students in the class, test scores, etc. But you don't know exactly how many you have. You have an idea, but you're not exactly how many. So right here are the output of what's going on in there. And you can see comment was added in. Let's go take a look at the integer version. So what you do is you put list, angle brackets, the data type, the name, equals new list, angle brackets. And instead of doing the values like I did up here, where I do the add method, I actually can do it at declaration time, just like that I did with arrays using the curly braces. So I have 1, 2, 3, 4, 5, 6, 7, 8. 8 values in here of 4 each to process. And it has a count, capacity, sum, average, min, and max. So I don't have to write much code at all. Let's put a breakpoint right here. And while we're at it, we're going to add breakpoints to sorted lists. We're going to add one for queues. And we're going to add one for stack. So that way we can look at them all. Alright, let's go. Times of the essence. Okay. I declare a list of integers that's going to have these values in it. I step through the code. It processes each value in the array. Not array, I'm sorry, the list. Getting my topics confused. Then we come down here and we ask for how many are in it. We ask for the capacity, the sum, the average, the min, and the max. And let's see what the output looks like. There we go. There they are. Notice we process them in no particular order other than how they were declared. We ask there is 8, the capacity is 8. The reason the capacity is 8 is because we gave it 8 initial values. We did not go beyond 8. There's the sum, the average, the min, and the max. A sorted list is where they're not used as often, but what you do is you have 2 values. Notice instead of having the word list, you put the reserved word sorted list, angle brackets, and what the 2 data types are. So we have a sales rep and their figures. So when you have a key, you have like a text value that allows you to access the numeric, or in this case decimal. It's like a paired value. We go through and we look to see if there's an entry in there. We add myself. We see, we add it to the list box, and then we process each value inside of it. And notice how you get at the values is you use dot key and then dot value. So this is the key and this is the value. It's like a lookup table. There you go. So we're going to go down and it shows you the pair, the key and their value, the key and their value. They're not used that often. A queue, think of a queue as you're at CVS in line, and the cashier will process each one of you one at a time in the order that you got into the line. So if I went to CVS and there was 3 people ahead of me, I would have to wait for the 3 people ahead of me to get processed, and then the cashier could take care of me. So let's do a queue. Notice you don't put the word list, you put queue. But everything else is pretty much the same except Q here and Q here. That tells C# that you don't want a list. A queue is going to be processed in first entry, oh, the wrong one. The first entry to the last. And how you enter things into the queue is you don't do add, you do on queue, and then you use a while loop, and you can use the dequeue to take them out. So this is what we call first in, first out. These people go in first, and these values get pulled out using the dequeue one at a time. Think of like you're on a website ordering holiday gifts, and your orders are put into the system. They're processed in the order of how they were put in. This is not used as often as lists, but you should at least understand that first values in get processed first out. So notice Boehm, Vasquez, Murick, and Candido went in that order, and we got processed in that order. A stack is like a stack of pancakes. Think that when you make the first couple pancakes, they go on the bottom, and then when you make a next batch, you stack them on top. So that means the hottest and freshest are on the top, and the first ones made are on the bottom. This is what we call last in, last out. Notice you use the word stack instead of list or queue. You still put the data type and you put stack here. Now to get stuff into a stack, you push it into the stack. Boehm, Vasquez, Murick, and Candido, and then you process them using the pop. Where they came up with push and pop, I don't know. But notice I'm the last one in, and I'm going to get the first one processed. There are times you want to do this where, like when you have inventory on the shelf, like in a warehouse, the stuff that was received most recently is probably closest to where the forklift is, and you would pull it out. And notice I'm using a while loop to process both the stack and the queue. What I want you to get out of this lesson, for the most part, is to remember that you have many options to deal with data that you need to keep in a group, process in a group, and you want to have them allocated in memory. You'd use an array. If you want them allocated in memory and treat them as a group, but you want some flexibility about how you process them, or you may want to add or remove values, you can use a list, a queue, or a stack. Okay.